Okay, electrophilic addition, halogenation of alkene with hydrogen bromide for unsymmetrical organic molecules. So the simplest unsymmetrical organic molecule for alkene is propene. So remember C3H6. So if we draw the structure formula, let's make like this. So CH3, here I have carbon, double bond carbon, hydrogen, hydrogen, hydrogen. So please, when you write or when you draw the mechanisms for the reactions, so it will be better to draw as displayed. So this part is displayed. So here I am adding hydrogen bromide. Hydrogen bromide. So hydrogen bromide is polar molecule. So bromine is electronegative, hydrogen is electropositive in this case. So hydrogen will have partial positive charge, where bromine will have partial negative charge. Okay, and remember the double bond. And double bond is electron-rich area. So electron-rich area attacks the hydrogen, which is electron deficient. And as it attacks the hydrogen, when it forms the bond, this bond between hydrogen and bromine breaks, so electron pair goes to bromine. Okay, so let's say that we have this is one first carbon, this is one second carbon, this is one third carbon. So let's say as a result, so as an intermediate product here, the hydrogen goes to the third carbon. So I will have CH3 carbon. So let me draw hydrogen here, and here I have carbon, hydrogen, hydrogen, and on the third carbon we say that we have hydrogen. On the second carbon, so remember the second carbon lost one electron, so it becomes positive charge. So this will form propyl carbocation. And remember, in our solution we have bromine. Okay, bromine which has negative charge because of lone pair. So this lone pair, so it is electron rich, attacks electron deficient carbon which has positive charge. Okay, so as a result, let me draw here. So as a result, we will have CH3 carbon, hydrogen. Here I have bromine. Here I have carbon, hydrogen, hydrogen, and hydrogen. Here I will have two bromo propane. Okay, so by IUPAC we have 2 bromo propane. Okay, so as you can see that I added that hydrogen on the third carbon. Okay, so what will happen? So let me draw where. So in the first case, so let's say the first case we had 2 bromopropane. So on the second case, so let me redraw this. So a little bit changed. So intermediate a little bit changed. So this intermediate, but the hydrogen goes to the second carbon. So I have CH3 carbon, hydrogen, hydrogen, carbon, hydrogen, hydrogen. So remember, so I added hydrogen on the second carbon, so that's why this carbon will have positive charge. Again, I have bromine, lone pair, and negative charge. So lone pair attacks our positive charged carbon, and as a product, in this case, what we are forming is CH3 carbon. So let me write like CH2. So I have 2 hydrogen and CH2 again and bromine. Okay, so now this one is 1 bromo propane. Okay, 1 bromo propane. So in the case when we have unsymmetrical carbon and when we're adding molecule which is unsymmetrical, okay, so we will form 2 products. Okay, practically we will form 2 plus. So we see 2 bromopropane and 1 bromopropane. So these products are isomers to each other. Remember, isomers, same molecular formula but different arrangement of atoms. Okay, different position of atoms. 2 bromopropane and 1 bromopropane. So in your exams, so you will be probably asked like predict the product. So for example, propane reacting with hydrogen bromide. So in this case, what you need to do, what you need to recall is Markovnikov's rule. Okay, Markovnikov's rule. Okay, so what does it say, Markovnikov's rule? So let's say Markovnikov's. So here I have again. Let me say that I have propene, CH3, CH, double bond, and CH2. Okay, so Markovnikov's rule says that the intermediate will have stable must have stable compound so intermediate must be stable. Okay, let's say so stable. So in the previous case, so here I have this intermediate and this intermediate. So let me draw this in both intermediates here. So here I have CH3, so CH and CH2. Here I have positive charge, and oh sorry, here I have CH3. Okay, and the second intermediate is CH3, CH2, and CH2. So third carbon has positive charge. Okay, so if we compare these intermediates, so these carbocations, this carbocation, so on the left side, is more stable. Why? Because this is secondary carbocation. Okay, secondary. What does mean secondary carbocation? So carbon which has positive charge is connected with 2 different carbons. This is primary. Okay, primary. So this carbon which has positive charge is connected with 1 carbon. Okay, so by Markovnikov, it's the secondary is more stable than primary. Okay, so electron density on the secondary carbocation is like more stable compared with this primary one. Okay, so as the secondary carbocation is more stable, the major product for this reaction, so major product for this reaction becomes, so here will form 2 bromopropane. Okay, so in order to predict easily the product, okay, major product for these unsymmetrical compounds, you can use this rule. Okay, so here in this case we're adding hydrogen bromide, so hydrogen and I have bromine. Yeah, so Markov says that intermediate which is more stable is more favored, so we'll form here in 2 bromopropane. And also you can use this rule, so hydrogen, so in this case so hydrogen bromide, so let me say, so in the yellow, so hydrogen, this hydrogen goes to the side where you have more hydrogen, so here. Okay, so please don't get confused, because this yellow by the yellow color I'm not showing the mechanism. Okay, just showing the product. Okay, so hydrogen goes to the hydrogen where the side where I have more hydrogen. So here I have 2 hydrogens, here I have 1 hydrogen. So, and bromine consequently goes to the side where I have less hydrogen. Okay, so bromine goes to the second carbon, so that's why the major product I have 2 bromopropane, and 1 bromopropane consequently is minor product. 1 bromopropane is formed from this primary carbocation. Okay, so don't get confused, major, minor products. and Markovnikov's rule.